So let's review our rules of refraction once again. If light travels from air into a dense material like water, it will always bend toward the normal line. And if light travels from a dense material into air, it will frequently bend away from the normal line. But there is another possibility. It may undergo total internal reflection. Maybe. So I wanted to remind you of what total internal reflection actually is. I have a semicircle filled with vegetable oil here, and if I shoot the light from the vegetable oil into the air, then I think you can see that it comes in right here, it travels in a straight line, and then it bends when it comes out here. This is what we expect, it's bending away from the normal line. But if I shoot the light in at a very large angle, then I think you can hopefully just barely see that the light comes in here, hits this point, and reflects out. This is total internal reflection. Total, because all the light stays inside of the vegetable oil. Internal, because it's inside, and reflection, because it's undergoing a reflection. So here is what total internal reflection looks like. If I make my angle of incidence, and remember we always measure angles relative to the normal line, if I make it very, very large, say this red line right here, instead of refracting out, it's going to reflect and stay inside of the material here, whether that's glass or vegetable oil, whatever dense material. So this path is total internal reflection. How do you know if an angle is big enough for total internal reflection to occur? You can tell by looking at your graph. So if you recall, when light goes from say glass into air, if we want to find the angle of refraction, we put their angle of incidence over here, because we're going from glass to air, and we move over, we figure out where it hits the graph, and this is our angle of refraction. But let's suppose our angle of incidence is 50 degrees, which is right here at the top of the graph. Well, we come over, and we've never actually hit the graph because it's way down here. So there is no solution. If our angle of incidence is 50 degrees, there does not exist an angle of refraction. And that means we must have total internal reflection.